Bonjour, je suis Ismail Cherkaoui, cofondateur de Hub Advisor, société de stratégie, de veille et d'acculturation digitale. Notre métier est d'aider les dirigeants d'entreprise à transformer leur organisation pour la rendre plus agile, customer-centric et data-driven. Pour apporter des réponses concrètes à notre communauté de dirigeants, nous interviewons tous les mois des pionniers du digital qui nous partagent sans langue de bois leurs réussites, leurs échecs et aussi les leçons qu'ils ont pu tirer. Dans nos interviews, on parle de choix technologiques, d'organisation, de transformation de la culture. Si vous êtes intéressé par des retours d'expérience concrets et pragmatiques, n'hésitez pas à suivre nos contenus.
Hello everybody, thank you very much for being with us today. We are very delighted and happy to have Nikola Ilic with us today to speak about data platform modernization. I started 1 minute before just to have a quick test. Can anybody in the chat room let me know if we can hear me well, please? It will be perfect. And meanwhile, Nikola, can you please as well start to talk and we will figure out if everybody can hear you.
Sure. So I just now started talking, so hopefully
perfect.
It's fine.
Now I have Kevin. Okay, a little bit echo, yes, but still people can hear us, which is good. So we are going to start the event first. Nikola, thank you very much for being with us today. We are very happy to have you online. Delighted. Very often, people struggle, to deliver business results because they are struggling with the data platform. And this is why we wanted, obviously, to invite Nikola today. I hear on a daily basis from chief data officer and head of data and even CIOs and CEOs, we need to improve our data quality. We need to have a more solid, a more predictable data platform who will support our business. And still, we have many questions about this particular topic. And Nikola, I know that you have prepared this call with us, and I let you obviously start the presentation of today and explain to us what are the pain points that you see and how head of data, chief data officer, enterprise architect who are working on this initiative can improve this area. Just before to let you start, in terms of the structure, so it will be a 30-minute presentation, but we want it as dynamic as possible. So anytime you have a question, please share it with us. Every 10 minutes, we will have a break. And during those breaks, we will have questions for you. We will handle the question that's coming from you, If you want to add anything, if you want even to talk to us, it's very, very possible. Just let us know. Nikola, I let you get you started.
Thank you, Ismail. First of all, I want to apologize in advance. So I got a little bit sick last evening. So if I have some cough, so if I coughing during the talk, please apologize for that. Yeah, but that's how it is. So let me first share my screen again, and then we can start, of course, with history lessons. What else? So before we proceed to explain how to create an efficient and modern data platform, we need to go one step back and learn some history lessons. And in the history lessons, in a typical traditional data warehousing scenario, you would have various operational source systems. Most often, we are thinking of relational database management systems, which were used to store transactional data coming from various applications. And these online transactional processing systems, or you will sometimes hear OLTP abbreviation, are designed that way to support quick, efficient, and secure insert, update, and delete of records. So the focus here is on quick data write. Because these systems were not suited for performing data analysis, what we had to do is to implement some additional steps to clean and transform this data from operational data sources before loading it into the central repository, which is called data warehouse. Data warehouse was, and still is, just to be clear, the focal point of the whole traditional data platform architecture. That's a single source of truth for all your organizational data. From there, we could build more department-centric data repositories called data marts, or connect with various business reporting tools and create all kinds of reports. Finally, we could have also written SQL code to generate ad hoc queries over the data which is stored in the data warehouse. And just one disclaimer, don't get me wrong, there is nothing inherently bad with this architecture. On the contrary, it served us so well for decades, and it is still serving us well in certain scenarios. However, things are changing, and they are changing rapidly, especially in technology. The same applies to data technology. It's not only about the fact that new technologies appeared on the horizon, but also the data itself changed its original traditional flavor. Now, instead of having structured data only, we also must deal with the data coming from, let's say, IoT devices, social media, images, video files, and so on. So let's examine what are the key pain points that we need to face if we stick blindly with these traditional data warehousing solutions. First of all, costs. Traditional data warehousing solutions, of course, we are talking about enterprise data warehouses. They are expensive to maintain. Reporting requirements change in accordance with the changes in data privacy laws and compliance demands. And the problem with traditional data warehouses was that they were very rigid in their structure, that any modifications meant a drastic increase in costs and timelines. This defeated the purpose of meeting real-time data requirements. Furthermore, older data warehouses run on SQL Server, Teradata, or Oracle. Although these are some of the best, really best databases in terms of performance, yet they have high licensing costs and maintenance expenses. So the overall expense is on the higher side. Next one is the non-flexible architecture. What does that mean? Today, the core requirement of every business, big or small, is agility and scalability. Ismail rightly pointed in direction of being agile. So the rigid or inflexible infrastructure and architecture of traditional data warehouses makes it very hard to bring in those changes rapidly. As a result, agility and scalability are hard to achieve. These problems arise because the architecture cannot be changed over the night, swiftly, on demand. So let me give you a very simple example. A small change in the data model can be done quickly in cloud-based data warehouses, but it can take anywhere from days to months in traditional data warehouse system. Complexity. Due to the non-flexible structure of traditional data warehouses, most organizations purchase additional hardware and tools to resolve their data challenges more quickly. This leads to a complex yet redundant architecture with several data repositories, each of which needs to be regularly maintained. And not just that, having so many isolated data stores can lead to inconsistent and unreliable business reporting. Further, it also leads to data accuracy, data integration, and data validation issues. The entire architecture can also lead to multiple versions of truths, since each data repository is responsible for its own reporting. Next one is slowness, related to the previous two that I mentioned. Because of their non-flexible and complex structure, traditional data warehouses usually respond very slow to every new challenge or requirement. Maintenance. We've already mentioned that introducing additional layers of complexity brings along additional maintenance overhead, which becomes more and more evident as new and fresh challenges arise. And finally, governance. From the perspective of data management, having multiple data silos raises the question of proper data governance and compliance issues. So those were the pain points. All these constraints that we mentioned previously required somehow finding a solution that can answer various data workload challenges in a more, let's say, robust, scalable, and efficient manner. And that's how the concept of the modern data platform was born. Before I show you how data platform concepts evolved over time, let's once again reiterate the process of a typical workload in the traditional data warehousing architecture. This is the illustration I've already explained previously. However, times are changing. Not that I want to say that traditional data warehousing solutions are dead. On the contrary, but let's say that they needed to evolve to support new flavors of data. So in the recent years, organizations acquire more and more data that's originating outside of the structured transactional relational databases. Things like social media data, images, videos, logs, information collected from IoT devices, and so on, which is, let's be honest, hardly manageable using traditional data warehousing solutions. So we are talking about semi-structured and non-structured data. So how do we handle these new flavors of data? We simply store them as it is in the data lake. A data lake can be used for storing all data types, structured, semi-structured, and non-structured. From there, again, we can perform our ETL operations, extract, transform, and load, to populate the enterprise data warehouse. And this part of the architecture on the left-hand side looks exactly the same as in the previous case. However, it's not only about different data flavors. It's also about new roles in data space. Individuals like data scientists or machine learning engineers that didn't exist a decade ago. So people responsible for providing predictive analytics over all data types, not only those residing in the data warehouse. So these new kids on the block had to respond to business questions in a whole different way compared to what we know and used previously. Therefore, by gaining them access to raw data stored directly in the data lake, we got a whole new architectural concept in place. And not only that, please pay attention to this arrow here. This one, if I zoom it a little bit, this one. So this ETL process is not a one-way street anymore, meaning it's not populating only an enterprise data warehouse, but also data lake itself. So essentially, we have two data storage locations here, a traditional enterprise data warehouse, but also an organizational data lake. Things become a little complicated, right? Obviously, we needed, or at least some of the individuals around thought that we needed, a more flexible and less complex solution. And that's when the latest concept was introduced. It's called Data Lakehouse. What else? I mean, if you combine warehouse and lake, what else you may expect than lakehouse, right? But why lakehouse? And what are the benefits of having a solution like this? Well, you may notice that this part at the bottom looks exactly the same. So we have structured, semi-structured, and non-structured data, and we store it again in the data lake. However, instead of physically moving this data from the data lake to the data warehouse, by introducing a metadata and governance layer directly on the data lake, plus performing all the ETL stuff within the lake itself, we are getting the best from both worlds. So what does this best from both worlds mean in real life? On the one hand side, we have flexibility, cost efficiency, and scalability of data lakes. On the other side, we can leverage features such as data management and ACID transactions. ACID is an abbreviation for some of you maybe who are coming from a traditional relational database world and have that background. This is related to enabling and supporting data integrity within the relational database. The main benefit of this new hybrid architecture is that various data teams can perform faster without needing to access and consume data from multiple different systems. Additionally, by eliminating the need for physically moving the data, Data Lakehouse architecture enables all the teams across the organization, data analysts, data scientists, machine learning engineers, to have the latest and most complete data available. Of course, however it sounds fancy and cool, you have to be aware of the specific prerequisites that enabled the rise of the data lakehouse concept. First of all is metadata layers. For example, we have an open source Delta Lake file format that supports transaction logging and ACID compliant transactions over files That's something that we had in traditional databases. Then performance. With enterprise data warehouses, you could have always relied on the performance aspect because of their powerful engines and other features that enable performance optimization. When we are talking about data lakes in the past, it was really slow to access objects in the data lake. Now with these new engines such as Polaris engine in Synapse, Microsoft Azure Synapse, or Photon in Databricks, you can write SQL queries and quickly retrieve the data stored in the data lake. And final reason is accessibility for data scientists and machine learning engineers. Don't forget, those folks in data scientist and machine learning engineering roles are usually super proficient with Python, with Spark, and similar technologies, but they are not SQL gurus. So exposing the data from the data lake directly to them, while giving them the possibility to continue using their preferred tools, is another strong argument for implementing a data lakehouse architecture. Let's briefly examine all the key features of this emerging new concept, or what makes this architecture a successful implementation. First of all, transaction support. In an enterprise data lakehouse, many data pipelines will often read and write data concurrently. Therefore, support for atomicity and integration of those transactions ensures consistency because multiple parties concurrently read or write data. Then schema enforcement and governance. Lakehouse should offer a way to support schema enforcement and evolution, supporting data warehouse schema architectures such as traditional star or snowflake schemas, and the system should be able to implement data integrity and have robust governance and auditing mechanisms. Then BI support. Lakehouses enable using BI tools directly on the source data. This reduces staleness and improves recency, reduces data latency, and lowers the cost of having to keep in operational way 2 copies of the data in both the data lake and data warehouse. Then storage is decoupled from compute. That means in reality that storage and compute use separate clusters. Thus, these systems are able to scale to many more concurrent users and larger data sizes. Many modern data warehouses, like already mentioned Azure Synapse, for example, also have this property. Open format support. This means that storage formats they use are open and standardized, such as Parquet format, and you can also use various APIs to connect to those files. Support for diverse data types, ranging from structured to unstructured data. So the Lakehouse can be used to store, refine, analyze, and access data types needed for many new data applications, including images, videos, audios, text, and so on. Support for diverse workloads, including data science, machine learning, and SQL and analytics. So multiple tools might be needed to support all these workloads, but they all rely on the same data repository. And finally, end-to-end streaming, which means that we have to be honest, real-time reporting is the norm in many enterprises today. So support for streaming eliminates the need for separate systems dedicated to serving real-time data applications. These are the key attributes of data lakehouses. Of course, enterprise-grade systems require additional features, such as tools for security and access control, data governance, including auditing, retention, and data lineage, and tools that enable data discovery, such as data catalogs and data usage metrics, just to name a few. With the Lakehouse, all these enterprise features only need to be implemented, tested, and managed for a single system instead of for multiple systems that we had in the previous architectures. Now, the fair question that I would expect is how to choose the right product. That's, of course, $1 million question. It's not easy, but let's try to demystify it a little bit. So instead of listening to vendor sales personas and convincing you that product X is better than product Y, I suggest starting by setting some guiding principles in advance. There are 3 potential data platform architectures, and you should start by determining which one is right for you. So if something is good for me, doesn't necessarily mean that it's the best solution also for you. So once you choose the architecture that best fits your business, choosing the specific product to build your data platform becomes much easier. So let's examine what are the things that affect choosing the right product. First of all, a data warehouse, which is a SQL-first data architecture. Choose this if majority of your users are analysts rather than programmers, meaning they can either write SQL or use a business reporting. They are proficient with using business reporting tools such as Power BI or Tableau, for example. The main advantage of data warehouses is that they enable self-service ad hoc querying by business users and similar things. Then we have a data lake. Data lake is a code-first data architecture. The most common programming language and framework are Python and Spark, but there are also support for other languages. Choose this if the majority of your users are programmers who do a lot of data wrangling by writing code to create ETL pipelines or train machine learning models. So then choose data lake. The main advantage of data lakes is that they permit flexible data processing by programmers. And finally, we have a lakehouse as a hybrid architecture that enables serving both business users and programmers. It supports both interactive queries and flexible data processing. And it can be built in one of two ways. First, you can make a data warehouse run SQL on data that is held in cloud storage in formats such as Parquet, for example. Alternatively, you can use a framework such as Spark SQL to run SQL directly on data lake storage. Both these are compromises, to be honest. A data warehouse operating on cloud storage loses many of the optimizations that make traditional data warehousing interactive and suitable for ad hoc querying. Also, at this point, I hope that you have decided which data architecture to use. So you know whether you need to turn to a SQL-first data warehouse technology, like maybe you heard about some of those products like Snowflake, BigQuery, Amazon Redshift, Azure Synapse, and so on, or a Python-first data lake one, which is Databricks is the biggest player in that area. The next decision is to choose the specific SQL-first product or the specific Python-first product. So how do you choose the right product? Once you define the right architecture, how do you choose the right product? First of all,
excuse me, Nikola,
yeah.
Maybe just here, you can even brief a little bit. Does anybody have any question at this stage? I'm always waiting a couple of seconds. If I see something in the chat, I'll let you brief as well. No, for the moment, we are good. So I'll let you go ahead.
No worries. Thank you. Okay, so now we are talking about choosing the right product for your organization. First of all, we need to distinguish between small versus large organizations. Now the question is, how small is small? The smaller your organization, the more sense it makes for you to favor simplicity. If your cloud data platform will estimate costs less than $300,000 per year, you are considered small. If your data platform will cost more than 1 million per year, you are considered large. What happens between 300 and 1 million? It depends. You should decide whether you are small or large depending on your engineering sophistication. So if you are a small organization, I strongly suggest that you have all your assets in a single cloud provider. Operating two clouds will mean that you will need to support cross-cloud data governance, negotiate multiple cloud contracts, and so on. So many headaches are waiting. The cost of this will greatly outweigh whatever extra efficiency the second cloud can bring to you. For large organizations with a large analytics and machine learning footprint, you have to make a decision on whether to choose a decentralized or standardized data platform. The more agile your organization, it makes more sense to decentralize the platform. Also, see if there are different departments in your company and users in those departments. You have a mix of various skills like SQL versus Python and a mix of workload needs. In such cases, let each department choose the data platform implementation that makes sense for that specific department. On the other hand, if you're more of a, let's say, top-down organization, choosing a single platform gives you higher cloud discounts and greater consistency, but the price you pay is less agility in your business units. Okay, so far we examined various general concepts and solutions that are relevant to modern data platform architecture. All these concepts that we previously talked about are tool agnostic, so meaning they can be implemented using almost any vendor-specific product or group of products on the market. However, I'll focus now on explaining how to design and build an efficient modern data platform solution by leveraging various services provided by Microsoft Azure. This is a simplified, yes, honestly simplified overview of the various Azure services which may be used to design an end-to-end enterprise analytics solution. It starts from connecting to multiple disparate data sources.
Maybe you can zoom your screen a little bit if you can.
Yeah, sure. Is it better now?
Yes, okay. It's better now. Yeah.
Okay, thank you. So, as you see, it starts on the left-hand side from connecting to multiple disparate data sources, ranging all the way from traditional relational databases to streaming data coming from IoT devices, and then ingesting that data in its raw form and storing it in different storage types based on the data flavor. This data can then be processed depending on the specific business needs, and finally it can be consumed. If I scroll down to the right side of this slide, it can be consumed through various applications and business reporting solutions. The focal point of the modern data platform in Microsoft Azure is Azure Synapse Analytics. So that's, let me show you. This is the icon that represents Azure Synapse Analytics. Wherever you see this icon, that's Azure Synapse Analytics. So it's here, here. You see that we have different stages in our end-to-end analytics solution that are covered by using Azure Synapse Analytics. Microsoft sells it as one product, but in reality, you can think of it more of an umbrella term covering a broad suite of different data services. So can you recognize the object on the screen? Anyone?
Yes, it's a Swiss knife.
Exactly. So that's Swiss Army knife. You can cut the paper, you can open a bottle of wine or beer, or you can cut some smaller items, all of that using one single tool. So if you're asking yourself, what on earth does this Swiss Army knife have in common with Synapse? Well, you can think of Synapse as a single tool that can satisfy all your data needs. Do you need to import data from multiple different sources? Synapse can do that. Do you need to transform the data before serving it? Synapse can do that as well. Do you need to store the data? Synapse offers different storage options. Do you need to query non-relational data or even files directly? Synapse can do that. Do you need to build machine learning models? Synapse can manage them for you. Finally, do you need to create your Power BI report straight from the Synapse? Yes, that is also possible. So that's why I said that Synapse is a Swiss Army knife for your all data workload needs. Let's do, I like to call it 10,000 feet high overview of different components that make Synapse Analytics a Swiss Army knife for your data workloads. For SQL professionals, remember we were talking about different types of professionals previously. So for SQL professionals, there are two pools in Synapse. Dedicated SQL pool, which is the official successor of the former Azure SQL Data Warehouse, and also serverless SQL pool. Developers that are familiar with Python, Scala, or Spark SQL can leverage usage of Spark pool in Synapse. Last but not least, Data Explorer enables quick and efficient analysis of batch and streaming data, so telemetry data, log data from IoT devices, and so on. Then when it comes to storage, there are also a bunch of possible options to choose from. starting with traditional relational way of storing data in SQL data warehouse, then Spark tables, Azure Data Lake storage, all the way to non-relational document-style databases like Cosmos DB. You can also orchestrate data movement using Azure Data Factory pipelines and mapping data flows. And finally, you can quickly visualize your data using, for example, Power BI. And watch out, here is the key takeaway from this story. You have all these tools, all these services under one roof, either natively or as linked services. And you can build, manage, and deploy your end-to-end data solution from within a web-based user interface, which is called Synapse Studio. The core part of this architecture, and I'm slowly finishing this story, the core part of this architecture in Synapse Analytics are analytic engines. And there are 4 different engines within the Synapse workspace. 2 of them are SQL flavored, already mentioned, dedicated SQL pool and serverless SQL pool, while the third is based on Apache Spark technology, and that is Apache Spark pool. The latest one, Data Explorer, still in preview, uses a special querying language called Custo. Maybe you heard about that. So it's great for querying, as I said, telemetry and log data. Also, 3 of them are provisioned: dedicated SQL pool, Apache Spark pool, and Data Explorer, which means that you need to provide some infrastructure in advance. While on the other hand side, serverless SQL pool is provided to you by default, and you can immediately start using it and querying your data from the data lake. It's a typical pay-per-query model. So if you're using serverless SQL pool, you will be charged just for the amount of data processed. So there is no costs for infrastructure, data storage, and so on. I think that was it. A short, brief introduction to Azure Synapse from my side. Any other questions, I will be happy to answer. Of course, if I know the answer. If not, then I'll try to get an answer and get back to you.
No, I mean, it's super clear. Thank you very much. Thank you very much, Nicola. I think you can, we just need the conclusion at this stage, or
yeah. So
you have anything else to introduce? Yeah. But for the moment, it's
the conclusion after all this story is that don't jump into conclusion then traditional warehouse is dead. It's not, but it needs to evolve. So it doesn't necessarily mean that Data Lakehouse is for everyone and for every company and every individual and so on. So you need to evaluate, but be aware that there is a solution that you can use to answer if you have these type of challenges. There is a solution, and this solution is called Data Lakehouse. Once again, don't trust all the vendor salespeople that will tell you that their product is obviously the best performing, the cheapest, and so on. Try to figure out what is your position and what is the let's say what is the majority of your data people in the company, and in which direction you want to go by leveraging those people, those data people. If most of them are SQL oriented, then go this way to more like SQL based platform. If they are more data scientists, machine learning engineers, writing Python code and so on, then go to this another way, which is more focused on using these programming languages. And finally, if you choose Microsoft as your vendor, you can be sure that they will cover everything in terms of this modern data platform architecture that we examined. I can't tell you exact costs. It depends on your data workloads, but you can be sure that everything is integrated under one umbrella. I'm also looking at the chat window. Still no questions?
I mean, yes. Here we go, Nicola. So we have a lot of, we have few nice comments. Thank you very much, Geoffrey. Thank you very much, Kevin. But I think it was not, we don't have so many questions at this stage. So unless you have anything else to share, Nicola, I think it's more than enough for today.
Yeah, that was it from my side. The only one thing I want to say, thank you for inviting me, and thanks everyone for joining. And I hope you get like a better understanding now of
Yes, and obviously, there are a lot of things to digest from here. But before to jump to let the audience go, Nikola is obviously an advisor at Hub Advisor, and if tomorrow we are working together and you want to go deep dive to the details, you want to have a customized consultation, this is typically what we can get from us. Nikola is one of our top advisors. If you want to discuss your data platform strategy, in a more customized way, obviously we can do that. I was very happy to have a lot of people in the room today, in the audience. We will contact you for further information to get to know each other and to introduce maybe further Hub Advisor, and to have you introduce yourself, obviously, to get to know more about you. Again, thank you very much, Nikola, and I'm sure that very soon you will have this one-to-one calls and meetings with all those guys who were here today.
Happy to help if I can. Happy to help, of course. Thank you.
Thank you very much. Thank you, guys, and have a nice day. Bye-bye.
Bye-bye.